Hello and welcome to the last unit. We're talking about linear correlation, and in the next series, we get into regression afterwards. First, though, let's really take a moment to just look at all the stuff we've done in this course. We started with just looking at a data set and getting some measures there, right? We found mean, median, mode, we found standard deviation, and also we talked about percentiles and quartiles. So we just discussed the characteristics inside of a data set with no other context. But then we started adding context, right? We looked from the population in, where we said, okay, we think the population has this type of behavior, whether it was normal or binomial or uniform. We even looked a little bit at t-distributions and chi-square distributions, and we tried to talk about how an individual or even a sample is behaving within that population. And then we looked from the in out, right? Based on this sample, how can I predict the population is behaving? And we started getting into confidence intervals and even hypothesis testing. That's so much accomplishment that we have under our belts here. So much done, right? We've looked at descriptive statistics and inferential statistics, things that have a definitive right answer, such as what is the mean or what is the median of these values I've collected. But then we've gotten into less easily answerable questions, such as what is the mean of the population, even though I don't have all of the data? And that's great. We've done so much, but we've only done it for one data set at a time. What if we start looking at more than one list or more than one set of values at a time? How could two populations be related to each other? Or maybe two aspects within a population? How could they be related to each other? And obviously, this is a big question that we're not going to be able to answer in just a few videos, uh, or even just a few days, or even a few weeks, right? There's a lot to say here. But what we will be able to do is get the ball rolling there. So we're going to talk about correlation in this series. And correlation is this. If two data sets are related to each other, then they are correlated or correlated. And you're probably looking at that and saying, wow, what great insight, Mr. Terrell. If they're related, they're correlated. Geez, wow. Okay, let's do this. Here's the definition we're going to worry about in this course. If we are having a linear correlation, that means that if we change the value of one variable or in one set, then the amount changed in the other set will be proportional and predictable all the way through its domains. And that was a little too mathy, so let's kind of back up a little bit. Right, so things that might be correlated. You can have two lists, right? Height for a person and their weight. Is that linearly correlated, right? If I increase the height of someone to a little taller, will they weigh a predictable amount more? And sometimes yes, sometimes no, right? But in general, maybe that's the case. We would have to test. Similarly, household size and garbage produced per person. Does that go up? Well, the total garbage goes up, right? But as the total number of people living in a house goes up, are we able to save on packaging? Can we get some bulk items? Will the garbage produced per person go down? We'll have to test to know. And similarly, temperature and time of day. As we go through the day, does it get hotter? Well, to a point, right? We would have to test to know. And the way we're going to test is we're going to make scatter plots. Scatter plots are where we take one variable, and that's one axis. The other variable is the other axis. And sometimes that's called labels in series. I think that's what Excel calls it. And you just eyeball it, right? We'll just start by eyeballing it to see if that is linear or not. So I'll tell you what, here is height and weight. I took the males out of one of the data sets we've been working with before. And you tell me, does that look linear or is that just a blob?